Okay, percent composition means you have to calculate the percent of each element in a compound. Now, percent composition problems appear in two ways. They'll either say provide the percent composition of water, for instance, which means you would have to give the percent of hydrogen and oxygen in a chemical formula, and then those percentages should add up to 100, and I want you to round to the nearest whole number because it'll make it easier. Or they will specify which element they want the percent of. So if they ask for the percent of nitrogen, and that's what you would provide. The percent of oxygen, that's the one you would provide. Okay? We're going to do a couple sample problems. Essentially, this is just a more detailed percent concept problem or a more specific percent concept problem, because we did percent concept in the beginning of the fall semester. So here, this is just another part over whole times 100 problem. So if we're looking at student exercise number 3, where I want the percentage of nitrogen in urea, which is N2H4CO. Okay, so they're specifying the percentage of which element they want. You're going to do the mass of nitrogen in the compound divided by the mass of the compound, and then you're going to multiply it by 100, and we're using the molar masses here. So you're going to have the mass of N2, or the molar mass of N2 on the top, and we're going to divide it by the molar mass of N2H4CO on the bottom. And then we're going to multiply it by 100. A student asked me earlier today, so you put the mass of the first element in the formula on the top. Not necessarily. It depends upon what they're asking for. Here they happen to be asking for the percent of nitrogen. That's why we're picking nitrogen, which happens to be the first one in the in the formula. They could have also asked you for the percent of hydrogen or carbon or oxygen. It just depends upon which one they specified. Okay? So if I look at the periodic table at nitrogen, nitrogen has a molar mass of 14.01. So I'm going to put that up on the top, and since there are 2 of them in the formula, it's 2 times 14.01. On the bottom, we're going to put the mass of the entire compound. So 2 times 14.01 for nitrogen plus 4 hydrogen at 1.01. Kind of messed it up here on the board. Let me fix it. Okay. And then we're going to add 1 carbon and 1 oxygen. Carbon is 12.01, oxygen is 16.00. And then we multiply it by 100 at the very end. If you're going to do this in one big step in your graphing calculator, you have to put the numerator in one parenthesis and the denominator in one parenthesis. If you use multiple parentheses, like more than one on the bottom, it's going to totally throw your answer off and you can't do it. Okay, so follow what I did here on the board. Okay, your percentage for nitrogen is going to end up being 47%. Notice I rounded it to the nearest whole number. Okay, now if I'm doing the percentage of oxygen in iron 3 sulfate, this is the chemical formula for iron 3 sulfate. I believe I messed that up in the chapter handout. I forgot the 2 subscript after the Fe, so you're going to want to make that correction. I want to put the mass of oxygen in the chemical formula, and I'm going to divide it by the mass of the entire formula. Okay, so here I have 12 oxygen because you multiply the 3 on the outside of the parentheses by the 4 subscript on the oxygen inside. So this is 12 oxygens. So it's 12 times 16 on top divided by 2 times 55.85 for Fe plus 3 sulfur at 32.07 plus 12 oxygen at 16.00, and then we're going to multiply it by 100, so it looks like this. And these are all molar masses from the periodic table rounded to the hundredths place, which is 2 places past the decimal. Okay, When you put all this in your calculator, you're going to end up getting 48% oxygen for your answer. Okay. Now, the worksheet for percent composition looks like this. Okay. I gave you the molar masses in parentheses after the problem, so you didn't have to go looking for them on the periodic table. This way, we're all using the same numbers. I may or may not do this on every other worksheet, but here, it's really handy. And I've been getting a couple questions on the first one, so I'm just going to sort of help you out on the first one. They asked for the percent composition of methane, which is CH4, which I gave you. When they ask you for the percent composition and they don't specify which element they want, that means they want all of them. So you need to calculate the percent of carbon and the percent of hydrogen. Okay? Now, since the since the percent compositions add up to 100 for a compound, you can find the percent of carbon or hydrogen and then just subtract from 100, and that's the other one you didn't solve for yet. So if I'm doing carbon, make sure you're putting the molar mass of carbon, which is just one of them, 12.01, divided by the molar mass of CH4 on the bottom, and then you multiply it by 100. So you're doing something like this. Once you get the percentage of carbon, you can just subtract that from 100, and that's the percent hydrogen, right? Because they should add up to 100 because we're looking at methane, which is a compound. Okay, so anytime it says percent composition, calculate the percent of every element in the chemical formula. If they ask you specifically for a single type of element, then that's the only one that you're calculating. Okay.